Hello everyone, welcome to MA 1203 Business Mathematics 2, and today we will learn about second order difference equations, which is a continuation of what we have learned last week about the first order difference equation. So this is the general form of linear second order difference equations. So we have yt plus 1 plus a1, so this is a constant yt plus 1 plus another constant yt equal to a function of t. Right, so this is linear because all of y is in linear form, and it is second order because the largest difference between the timestamps is 2. Yeah, so t plus 1 and t. So the solution of this difference equations will be in the form of yt, which is a summation of what we call the homogeneous solution and the particular solution. Yeah, so how to get the first solution, which is the homogeneous solution? Of course, by considering the homogeneous equation. So it is exactly the same as in the general form, except for on the right hand side we don't have the function bt, but instead we have 0. So if on the right hand side is 0, then we call the equation is homogeneous equation. So the question is now how to find the solution of this kind of equation. All right, so just assume that the solution is in the form of r to the power of t. Yeah, okay. So if yt is r to the power of t, of course yt plus 2 is r to the power of t plus 2, yt plus 1 is the power of t plus 1, right? Okay, so in that case, we just substitute all the assumption of the solution into the original homogeneous equations, and we get this, right? And of course, we can take out the r to the power of t, yeah, and we have this equation, yeah. So notice that the one inside the bracket is a polynomial of degree 2, right? So we give a special name for that polynomial of degree 2, which we call the characteristic equation. Yeah, so this is the characteristic equation, and this is equal to 0. Yeah, and if this is equal to 0, it will have roots r1 and r2. Yeah, so now the solution, the homogeneous solution, will be depends on these roots of the characteristic equation, right? If the roots are real roots but they are different, yeah, then we will have this homogeneous solution. Yeah, so a constant times the root to the power of t plus a constant the root to the power of t. Yeah, remember originally we assume that the solution is r to the power of t, but we get two roots. Yeah, so we have to use both of them, and we use linear combination. Yeah, okay. But now if we only have one real roots, yeah, so the roots are the same here, r1 equal to r2 equal to r, then we will have this one. Yeah, the homogeneous solution will be c1 r to the power of t, but of course we cannot add another r to the power of t, so we have to multiply with t. Yeah, of course there is another possibility of the roots r1 and r2, which are which are complex roots. Yeah, but we will not learn about this in this course. All right, so let's see an example. Yeah, so if we have this equation, yeah, how we will find the solution? Yeah, and of course we let y is equal to r to the power of t. Yeah, and as in general solution, we substitute, we have r to the power of t plus 1 minus 6 r to the power of t plus 1 plus 8 r to the power of t equal to 0, right? Okay, so we can take out the r to the power of t, and it becomes r squared minus 6r plus 8 equal to 0. And we have a characteristic equation, yeah, characteristic equation, which is r squared minus 6r plus 8 equal to 0. Yeah, want to find the roots of this equation, of course, we have to factorize this equation, and it is gonna be r minus 2, r minus 4, right? And we have r1 equal to 2, and r2 is equal to 4. And then, of course, remember what we have before. We have the solution. The homogeneous solution will be equal to C1 2 to the power of t plus C2 4 to the power of t. Okay, so that is the first example. And now let's see another example. So very similar again. We assume that yt is equal to r to the power of t, and then if we substitute, we will get r to the power of t plus 2 minus 4r to the power of t plus 1 plus 4 equal to 0. Yeah, and then here we can have this is r to the power of t. Yeah, and we can take out the r to the power of t, and we will get r squared minus 4r plus 4 equal to 0. And then the characteristic equation is just r squared minus 4r plus 4 equal to 0. And we can factorize this one is just r minus 2 square, right? And in this case, we have r1 equal to r2 equal to 2. Yeah, and this is the second type of the roots of the characteristic equation, and we will have the homogeneous solution will be equal to C1 2 to the power of t plus C2. It's supposed to be 2 to the power of t, but this is the same with the previous term, so we have to multiply with t. Okay, so that's the second example. So that's the first part of a second order linear difference equation. And I think that's all for the first video. We will continue with the next video.